This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio brings you relevant and detailed discussions about software engineering topics at least once a month. Thanks to our audience and the partners listed on our website for supporting the podcast. Welcome to a new episode of Software Engineering Radio. This time we have an episode with Martin Fowler and Rebecca Parsons about domain-specific languages. And as usual, we start with our guests introducing themselves, although I don't think there are many listeners who don't know you guys, but we should still do that. So, why don't you introduce yourself?
Well, I'll start off. My name's Martin Fowler. I'm a internet loudmouth who speaks a lot, incessantly, on the topic of software development. And my particular interest in domain-specific languages was reinforced by the fact that I spent rather more years than I'd like to think writing a book about them.
Mm-hmm. And my name is Rebecca Parsons. I'm the Chief Technology Officer for ThoughtWorks. I've got a strong background in programming languages, and I've always been something of a languages geek. And the work on domain-specific languages with Martin, I was primarily focused on it from the programming languages perspective, but I also have a significant interest in helping businesses build software better, and we believe in the long run, domain-specific languages are a good way to go about doing that. So we're excited about the opportunity to make more people familiar with domain-specific languages and hopefully give us some new use cases for them.
Right. Well, okay, so I guess we should start by first defining what a DSL, a domain-specific language, is, since we've already been talking about it. So who wants to go?
Well, I should go with that, and of course I should have the definition right in front of me that I used in the book. Hang on a moment. Okay, so I have here the standard text on the subject. So nice to be able to say that. And in it I have a definition. So I define it as a computer programming language of limited expressiveness focused on a particular domain.
Okay.
And I talk about how there are elements to this definition. There are four of them. One is that it is a computer programming language, so it's not something like a business terminology or something of that kind.
Right.
The idea of trying to build computer systems with a consistent business terminology using what the domain-driven design people call a ubiquitous language is a good idea, but a domain-specific language is something that's executable by a computer.
Right.
The second thing is that it's a language, so it has a kind of language nature, which is a rather fuzzy definition, but it should have this quality that it feels like some kind of language, not just, for instance, a sequence of API calls or something of that kind.
Mm-hmm.
The third point I make is that it's of limited expressiveness. And that's something, I guess, that I've particularly focused on in a way to distinguish domain-specific languages from general-purpose programming languages. So, to me, the interesting thing about domain-specific languages is that you can't write an entire system in a DSL. You can only use it for sort of point parts of the system.
Right.
And following from that, the fourth point is that they tend to be focused on a specific domain.
And I would also say, from a programming languages perspective, that what constitutes a language, although in our nomenclature it's very often fuzzy, there are specific aspects of what it takes to be a language. And one specific part of that is, what is the syntax of the language? What does it look like? What constitutes a legal sentence? And in the context of a domain-specific language, you want that syntax to make sense to within the construct of the domain. And then the second aspect of a programming language that's useful in this context is the semantics. What is the behavior or meaning that is expressed by a particular legal sentence? And so when we think about creating a domain-specific language, we have to have an understanding of what are the concepts that exist within this domain that we want to be able to express with this computer language. What is the behavior that might manifest as a result of manipulating these concepts? As Martin points out, it has to be an executable language. And then the third thing is, what is a natural way for people within the domain to put different constructs together from their domain into something that would constitute this executable behavior.
Right. I mean, this topic of limited expressiveness is, of course, interesting, right? I mean, does this mean that all DSLs have to be declarative, whatever that exactly means? Or, I mean, some people say that if a DSL contains things like expressions or statements, then it's not a DSL anymore. So can you maybe grasp that a bit more concretely, this limited expressiveness thing? Because I struggle with it all the time.
Yeah, well, it's one of those vague boundary condition things. For me, it's really was triggered out of this, what makes the difference between a DSL and a general purpose language. Being focused on a domain is not quite enough. The example I often throw in is the R language, which is used for statistics.
Yep.
And it's a very complete language. You can do all sorts of things with R. And although it's focused on the notion of statistics, its power is such that it has a different feel to the kinds of things that, I mean, I was thinking of things like regular expressions or CSS or something of that kind. I mean, you could argue that COBOL is a domain-specific language targeted at certain kinds of business applications.
Yeah, just a very big domain.
Yeah, and so the boundary condition when focusing on domainness didn't feel very good. But when you begin to explore, well, it's really about limited expressiveness, then all sorts of other things come out of it. In particular, for instance, one of the arguments against using domain-specific languages is that it's complicated to build your own parser, for instance.
Yep.
But if it's a domain-specific language with limited expressiveness, the problem is way smaller than it is than if you're doing a general-purpose language. And that affects a number of things, I think, in language usage and design. If you have a simple language, a lot of the things we assume for general-purpose languages aren't true.
Right.
I would also say that the question about expressions depends significantly on what domain that you're talking about.
Yep.
A physicist, for example, is quite used to working in complex mathematical equations, and trying to say a domain-specific language that would be talking about physics wouldn't have expression or equation-like concepts would be ridiculous.
Yep.
However, if you look at a marketing application where you're building business rules for determining offers that might be going to a customer, much more than simple addition and subtraction or maybe percentages would not be natural within the domain. So we do have to think about it from that construct. I do believe part of the reason that DSLs have been so hard to work with in the past, though, is the fact that when people start with the limited domain, then they toss in, well, we need conditionals, then they toss in, we need iteration, and all of a sudden you've got a general purpose programming language that happens to have some accounting principles in there as first class objects. And so the ability to segregate these domain scripts from the other processing that goes around them, I think it is a critical component for us to be successful in domain-specific languages. I don't think that implies it has to be declarative, though. There's still procedural or behavioral aspects to it.
Yep.
But we do want to make sure that domain language doesn't get big enough to become Turing complete.
Yeah. Well, okay. Let's leave it at that.
That might be a bit too extreme, but not too far.
Actually, I
look at Turing completeness as a smell.
Yes,
right.
I would
it's
agree.
a sign that there's something probably wrong, but it certainly isn't an absolute sign of a problem.
Yes. Yeah, absolutely. So you also mentioned before that a DSL is more than an API or a framework. And now there are, of course, internal and external DSLs, where internal DSLs are embedded in a host language, which brings them potentially dangerously close to APIs and frameworks. So can you try to draw the boundary first between frameworks and internal DSLs, and then obviously regarding external DSLs?
Well, this is another of these very fuzzy boundaries, I'm afraid.
Yep.
It's essentially, if you look at it in its sort of very simple elements, yes, an internal DSL is just a string of API calls. But what's interesting comes down to this part of our definition of it having a language nature. that you should, when you're writing an internal DSL, although you happen to be writing Ruby, if it's a Ruby internal DSL, or Lisp, if it's, well, less so in Lisp's case, you shouldn't have a feel that I'm writing Ruby. It should feel more that I'm writing this internal DSL.
Yep.
And I think what it boils down to is that with API calls, when we try to design an API, we try to make each API call stand on its own. Its naming, its definition, and ideally we should have a limited amount of temporal linkages between when we make the API calls. Mm-hmm. And we typically understand them by reading down something like JavaDoc, and it's one method, another method, another method. But with an internal DSL, they're designed to be composed together in sentences. So individually, the methods may not make much sense. You'd look at them and say, well, that's a stupid name. And some of the ways in which it's, the way it takes its arguments and that kind of thing just doesn't make sense if you look at it standalone. But it makes sense in the context of a sentence. And that, albeit a very fuzzy distinction, is, I think, the one that separates out internal and external, internal DSLs from APIs.
It's certainly the best definition in that sense I've ever heard, because there isn't, people just say things like, well, it has to feel like a language, but what does this mean? And I think your attempt, or you're tying this to the names of the methods and the independence of the methods from each other is a very good way to put it.
Yeah, that was hinted to me in a conversation I had with a former colleague of ours, Mike Roberts. And he said, is the difference between an internal DSL and an API that an internal DSL has a grammar? Mm-hmm. And that was really what triggered that thought of thinking, well, of course, you can argue APIs have grammars, but they're very limited grammars. With an internal DSL, you've got a little bit more. And hence that led me to this thought of the sentence becomes the fundamental concept of an internal DSL.
However, internal DSLs don't use formal grammars to specify the valid syntax of a structure of sentences, right? I mean, that's one of the main principles that distinguish them from external DSLs, where you usually do use a grammar or something similar.
Well, I would assert as a languages type that even if you don't write down the grammar and a formal grammar specification, you have a grammar for your language that does exist, and that grammatical structure does imply the relationship between the different aspects of the sentence. It is obviously more explicit in the external DSL case, but in the internal DSL case, there is still a grammar, because you have to have some way of mapping between these structural elements in your sentence to the semantics that are supposed to result from the combination of those things, whether it be nesting, whether it be modification of a clause, all of the different syntactic approaches that we have for building up a grammar. Those are the ways these different semantic domain concepts can be related to each other.
And that's something I flowed into the book a bit more, because when I was looking at the various techniques you have of combining elements in an internal DSL, I found there was an interesting correspondence between which techniques you'd use and what was your logical grammar that you might have in place. Certain grammar constructions implied certain ways of using language constructs. And I found that a very helpful way of thinking about your options when it comes to an internal DSL.
Right. So is it fair to say that all languages that are friendly to internal DSLs have some of the same language features, like the ability to avoid parentheses or commas or something like that? So is there like this set of language features that makes the language DSL friendly?
I suspect so, although it's not something I thought about in a huge amount of depth. Okay. But yeah, certainly the minimizing of unnecessary punctuation, whether it be keywords or simple things like commas or parentheses, certainly helps. I think it also, there are certain constructs that are useful. For instance, the ability to have closures is really useful, because it allows a hierarchic nesting that is otherwise difficult to achieve. It's a hierarchic nesting combined with being able to alter the execution order, which is useful for that. In addition, I think syntactically significant white space, like Python, actually becomes a problem for an internal DSL, because if you want because often you want to format your DSL differently to the way the language normally is formatted,
right,
in order to bring out the DSL-ish quality of it. And if you've got if your indentation is syntactically significant, you can't do that. And so I think that's a hampering piece as well.
Okay. So one benefit, I think, of internal DSLs is that they potentially can interact very well with the host program. Although that, of course, can also be a disadvantage if you want to disconnect the domain people from the implementation. So you want to elaborate a bit on these, trade-offs, embeddability, composability with GPLs, and domain expert, usability?
Well, that boundary condition, I think, is really quite interesting because it really does cut both ways. I mean, some problems, it's really nice to be able to mix easily between the DSL and the general purpose language. And that's where an internal DSL is very, very suitable. The example that immediately springs to my mind there is build description systems, such as Make, Rake, Ant, and the like. I've definitely come to the view that having an internal DSL, which is what Rake, the Ruby build system, uses, is much better than having an external DSL, which is what Make and Ant effectively have. But there are other problems where it's good to have a hard line, where you say, we don't want to, if we let that line be too fluid, then it's too easy for a host language to overwhelm the DSL, or for people to write expressions that go outside of the boundaries. So it really, I think, depends on the problem as to whether you want something with a hard boundary or a very fluid boundary. And so that's really an interesting case of sometimes good, sometimes bad.
Yeah.
And I would actually turn the question around a little bit. One of the problems with an internal DSL is that you are bound by the syntax and the computational model of your host language. And if you buy the assertion that what we're trying to do is express things naturally within a domain, if what is natural within that domain does not map cleanly to the computational model or the syntax of the host language, you're going to have to alter what you would like to do in the domain language to make it possible to be in the internal language. So I would like to start from what is the requirement of the language, but then, of course, I'm a languages person.
Well, I mean, I think it's really interesting. I mean, if we go back 2 or 3 years or 4 years and at least stay a little bit in the mainstream, we had tools like Antler or Xtext, which were basically tools for building standalone external DSLs, and there were internal DSLs in the languages you already mentioned. Now, things are changing a bit, right? I mean, for example, with Xtext, while you can't easily extend Java, you can include an existing expression language, XBase. In MPS, you can easily extend Java or C. So, and not in a way where you use meta programming with the host language, but rather by really literally extending the language definition. So that is another form of, if you will, embedded DSL. It's not really internal in the sense as you've defined it, and it has many of the advantages of both. You get tool support, you get a real grammar, or whatever the formalism is, and you still get close integration between GPL and DSL. So I think interesting things are happening there to give you more options in this space.
Yeah, I mean, it was something we experimented several years ago with Intentional, the idea of just composing different languages within the same piece of script. And it's particularly nice for something like where you've got a system that's doing SQL, and you can put the SQL right in there, you can put your code right in there, and you can also have very nice linkage to test cases right in there as well. And I thought that was a very interesting direction to take. But this is where you move into we're going to need more sophisticated tools, which of course is what things like Xtext and MPS are pushing towards.
Yeah. And maybe just as a teaser, not too long from the time when you hear this episode, there will actually most probably be an episode on SE Radio which explores this idea a little bit further. Okay. So, and we'll talk about some of the tool aspects later again. So another concept that I find very prominent in your talks and in your book, and which I don't always agree with in terms of the prominence you give it is the semantic model. So can you elaborate the difference between the semantic model, the meta model of the DSL, the abstract syntax, all these things?
Okay. The example that I like to use to think about this is if you've got something that you want to model using a state machine construct. If you have a problem where you've got to deploy 100 different systems and they all have slightly different behavior, but their behavior can be nicely captured through a state machine, then a natural route to go, certainly if you're of a modeling direction, is you say, well, let's build a model of state machines, and then I can populate it 50 different ways for 50 different cases. And that's something database people do by having state machine things inside databases, or object people do by creating object models of state machines, etc., etc. Now, a DSL can be used as part of that, because a good way to express a state machine so that you can write state machines down is to do it in terms of writing a DSL. But what you've then got is this concept of a model of state machines and a DSL that is able to express things in terms of state machines. And my feeling is that they are both very important. And what's more, there's actually, in many ways, more importance to having a good model. A lot of the advantages and disadvantages that people state for DSLs can actually be stated in terms of whether they've got this kind of model or not. They may call it a library, they may call it a framework, but it's fundamentally a thing that allows you to express things in terms of that model. What the DSL does, I refer to it as a thin veneer over the model, because it really just allows you to express what you're doing in that domain a little bit more cleanly, but it's then going to populate that model.
Mm-hmm. So a DSL as a syntactic facade around a potentially complex framework. Yeah,
and the point is, I've seen a lot of DSLs implemented that don't use this approach, but the problem, the advantages of having a clear model is that, for a start, it allows you to express semantics in terms purely of the model without worrying about the syntax of your DSL and how you're going to parse it and all that kind of thing. It allows you to test the model independently of how it's populated through the DSL, and that, I think, is a very useful separation of concerns.
Mm-hmm. I think it's also important to distinguish between an abstract syntax tree and a semantic model. There may be a close correspondence, but there may not be. And if you think about things again from the perspective of the domain and what this DSL is trying to express relative to the domain, you have concepts in that domain, and there are behaviors that you want these concepts to be able to manifest, and that's the semantics of that domain. And you can start from the domain. What are my sensible? I'm trying to avoid using the word objects. That's why I'm saying concepts, because this isn't OO necessarily even. Yeah. But so I have concepts within my domain, and I have behavior that might manifest itself in my domain, and there is something that constitutes interaction in my domain that might look like a procedural step 1, step 2, step 3 or workflow, but it might look like something very different, like a state machine behavior, as an example. And so I can talk about the semantics of this language in the language of the domain, and I could talk about the semantic model in that context, and then I simply look at, okay, what is the syntax that I want to layer on top of this to allow me to populate the representations of these concepts that I have in my language and to express the behavior that I desire of these concepts. Yeah. So separating out the syntax tree, I think, is important, because the purpose of the syntax and the purpose of that semantic model are in fact quite different.
Mm. I mean, the reason why I sometimes disagree a bit is that, first of all, in embedded systems, you can't do it often because you have to be very efficient. You can't have a big framework. So that's one thing, right? You don't want to just populate a framework. You want to generate very optimized low-level code. So
hang on that point. I mean, in the embedded systems you're talking about, do you have the parser for the domain-specific language as part of your embedded system?
No. Of course not.
Well, that's the point, right? Once you have a semantic model, and I didn't talk about this earlier on, but it is a follow-on thing, you can then choose to execute that semantic model directly, effectively by interpreting it, or by doing code generation off the semantic model.
Okay, then we're talking about two different things and we need to clarify. There is the idea of having a framework, maybe one that already exists, or maybe one that you've built for the purpose, for which you then build a DSL, which basically populates the framework and then the framework runs. That does not work in embedded systems for the reasons of the overhead. Of course, what you can do and maybe should do is you have a cleanly defined semantic model which you then either generate or interpret. In embedded systems you will probably generate, and that is something you decouple from the syntax and the abstract syntax.
Right.
But these are two different things.
Oh, I guess I see them as the same thing. It's
Okay.
just how you got there, right? If you've got an existing library or framework, you might say, okay, I'm going to make that be my semantic model. But if you're going from the beginning, you'll build the semantic model and your DSL syntax typically hand in hand together. And then, of course, it depends on the circumstance whether you need to generate or not off the semantic model.
Yes, and going one step further, depending on the tool I use, the language structure will be very close to what you would ideally define as a semantic model. And then you can argue whether you actually need two of them, right? And that is basically my point. But okay. So we've solved that.
The important thing for me is that, particularly with code generation case, you don't go directly, you don't write in your grammar file the generation code off there, which I have seen people do.
Yeah.
That's where I feel there's an opportunity to separate concerns.
Okay, but, I mean, we shouldn't probably discuss this forever, but if you use, for example, Xtext, you write a grammar, the grammar automatically creates a meta model, which is the abstract syntax of your language, and then you generate code from that. So you don't embed generation stuff in the grammar, which is this is that's bullshit, right?
Yes.
But I would not, in this case, create yet another, let's say, EMF eCore file for the semantic model and then transform the abstract syntax created by Xtext into that one and then generate code.
Yes,
Right.
but that depends on the qualities of your semantic model and how closely that maps to what is the natural syntax within the domain. It might make sense to go directly from the syntax tree. It might make sense to go from the syntax tree to a model that makes it easier to do the code generation. And that's going to be very problem specific.
Yeah.
Okay.
I mean, for instance, if you're evaluating arithmetic expressions, then an abstract syntax tree is an excellent semantic model.
Yep.
You can have the same artifact playing two different roles, and that's perfectly okay.
Yeah. Well, then we agree.
I think so.
Violently.
Makes it boring. Okay, you already touched the point of interpretation versus code generation. I think we should cover that to some extent. I guess people know it from interpreters and compilers. It's basically the same story, right?
Yes. Yep. Basically, when you're looking at interpretation, what you are executing against is this semantic model, whether it be an abstract syntax tree or some other representation. And it's within the compiler world, you're very often working off of either an abstract syntax tree or some other internal representation of the program, be it a program dependence graph. So it's exactly analogous in that context. And the nice thing is you can make the same kind of choices that you can make in a language Scheme, for example, you can both interpret and compile directly to native code. You have the same kind of choices where you can have the moral equivalent of the read-about print loop to do quick debugging and such in your DSL, and then when you want to, you can compile it down to something or code generate for more efficient execution. So there is no conceptual difference between what's going on here in DSLs and what we talk about in programming languages and compilers.
Mm.
And with perhaps an extra twist that when you generate code, you actually have the choice of, do I actually generate effectively a model in data that I interpret in the generated code structure, or do I just go for straight ahead code with no notion of a model in there?
Yeah.
And that has its own trade-offs. But that's an independent decision of all the other pieces of the DSL chain.
There is another nice thing that helps to confuse people, and that is that code generators are actually interpreters, because they interpret the model and as a side effect they generate code.
Yes, exactly. The output domain for a code generator is is native code, and that happens to be just different than the actual domain.
Yeah. So what I would like ideally is to write an interpreter and then have some magic of automatically deriving a compiler for that. I think this is known as, that's kind of beyond what I really talk about, but I think it's called a partial evaluation. Is that true? Anyway, the point is, have you come across, I mean, I know there is work in compilers in that space, but have you come across that kind of approach in DSLs where you can automatically derive a compiler for a target platform from an interpreter that you've maybe written in some abstract specification?
DSLs are not nearly that sophisticated yet. I certainly haven't seen anything that's equivalent to that in the DSL space.
Okay.
There are certainly ways that I could imagine that you could do such a thing, but I certainly haven't heard of it being done anywhere.
Okay. I mean, the first ingredient you would need there is actually some kind of formal way of specifying the semantics, and that is an interesting question in itself for DSLs, right?
Exactly, and you know, the way I can actually see it happening is if you do have something that is more closely tied with a framework where you actually have more of an ability to take advantage of some connection between something you have in your semantic model and executable code you already have available to you with this framework.
Right.
So that's probably the obvious analogy that I can see at the moment, but I don't think that's something that's going to be. I don't think that's going to be a popular early topic. Right. We still have a whole lot of questions in terms of just what constitutes a good DSL, where the boundaries go, and trying to get that far down the road, I think is still quite a ways off.
Mm. Okay, so let's come back and address some more practical topics again. After this theory, why would one use DSLs? What are the benefits?
There are two primary benefits that I tend to talk about. The first is simple programmer productivity. And for this, my example is regular expressions. I mean, they're a very cryptic construct and all the rest of it, but if you look at a regular expression and you compare it to the code that you'd have to write without the regular expression, it's much easier to understand and modify the regular expression. And so a lot of DSLs just help in that terms of programmer productivity. I mean, that's part of the reason why Rails got so popular, because they express so many of what they did in these little DSLs scattered around the framework.
Right.
And people like that. That is in itself is enough in a lot of cases, I think. But there's also a bigger prize out there, which is, for that, my example is CSS. Now, that is a programming language, but most of the people who program in it don't think of themselves as programmers. They think of themselves as web designers. Mm-hmm. And they're describing this really quite complicated language in terms of its semantics. But they're able to manipulate it in terms that they at least have some sense that they understand. Now, the value here is not so much that with this kind of DSL you want domain people to be writing it themselves, although there are certainly cases where it happens. I think the biggest gain is if you can get to a point where domain people can read the DSL and have a conversation based on it with developers.
Or pair program.
Because then...
Or pair program.
Or pair program. Because then what you've got is a very rich information channel between domain people and developers. And since that divide between domain people and developers is, to my mind, the biggest problematic divide we have of many divisions in software development, anything that can bridge that gap is really nice. Now, of course, it's not easy to be able to pull that off, but the benefits can be quite huge in doing so.
Right. And just as a remark there, I kind of distinguish between like application or business domain DSLs and technical DSLs based on the target audience. And many of the trade-offs we've discussed before also kind of hinge on this thing. I mean, for example, external DSLs with good tool support are better for domain people, whereas internal DSLs with tight integration in the programming language may be more interesting for technical people. So there are some relationships there. I think.
Oh, absolutely. I think internal DSLs are particularly attractive if your only audience is programmers, because then they get to program in their regular language, particularly if it's a language that's suitable for DSLs.
Yeah.
But as you move to more external people, then the freedom of syntax and the freedom of semantics that you get with an external DSL become a lot more attractive.
Right.
Well, and even just the expectations of the tools. I know that developers with IDEs, they're very bound to the keyboard shortcuts, and there are methods of interacting with a development environment tool for a developer that seems very unnatural for business people. When you watch someone who is a true wizard at manipulating an Excel spreadsheet, they don't interact with that development environment in the same way that a truly expert developer interacts with a Java IDE or with Visual Studio. And so the expectations that you have around tools are very different as well, and how you can provide a tool that is natural for someone in a domain is very different as soon as you get out of the technical domain into the application domains.
You mentioned the E word. Is Excel a DSL?
No, I think it's a general-purpose programming language.
Okay.
But it is absolutely a general-purpose programming language and a very interesting platform because of the fact that it is the most widely used programming language by people who don't consider themselves to be programmers.
Yeah. There is another connection there. I think wherever Excel is used, a DSL is lurking somewhere.
Yes, I would agree.
So
Yes.
there's actually a research project going on at the Technical University in Delft, where they are working on exactly that connection, where they are trying to understand why and how people use Excel in business contexts, and see to what extent DSLs can be a better solution there. Any other advantages of DSLs before we look at the downsides? No free lunch, of course.
Well, I do think one of the important advantages, particularly of an external DSL, although you can pull it off in an internal one, it's more difficult, is that you can express the behaviors that are associated with those domain concepts in a way that's natural to the domain. And this gets into these alternative computational models, right, where you can actually think about a problem and model it and express it as a data flow system, even if you are going to execute in a completely different computational context. And so for not so much potentially in business domains, but when you start to think about scientific domains, that ability to change computational models, I actually think is an important one. And trying to figure out a way to express a concept not only that is not natural in the programming languages, but even the behavior is a stretch. I mean, programmers are stubborn. We know how to take an object-oriented language and make it do whatever we want it to do. But if it's not natural in that language, it's going to be even more difficult for the domain person to really understand what's going on. And so being able to separate out the semantics of the model with this alternative computational model and then build the execution engine for that separately, I do think is an advantage and some place where you would look to use DSLs. That also provides us a way where we can start to address some of the performance characteristics as well, where if you're looking at particular scientific computations, this computational model might be more efficient than that because we know some things of the characteristics of the data. And so those are things, if we can separate those things out, it's easier to express than trying to explain to someone, okay, well, you've got to write 2 versions of this program because if your data looks like this, you don't want to run it the other way.
Yeah. I mean, yeah, go ahead.
Yeah, I think that the alternative computational models is particularly interesting to me because I've come across from time to time teams that will build this rich semantic model as part of their domain in there that's incredibly productive, but it's a mixed bag because for people who understand that semantic model, they can do an enormous amount really quickly, but a lot of people find it very difficult to learn and very difficult to approach.
Yeah.
And so one of my hopes is that people, by taking on DSLs, will say, by making a DSL as a front end to this rich semantic model, I can actually make the whole thing more approachable because instead of them looking around inside data structures trying to find out where the program is, they can actually see the program in a much more explicit form.
I mean, what really is interesting, I mean, when people start using DSLs, they often do that because they think, we can write programs in a more concise way and we can generate all this crappy code we don't care about. So that's the first look at DSLs. Then at some point they notice, actually there is another benefit. The syntax can be so that we can integrate domain experts and we can capture our business knowledge. So that's kind of the next step. And then even further, people come about these alternative semantic models and notice that based on this, they can do much more interesting things, not just in terms of writing less code, but making more interesting analyses, proofs, correctness, constraint checking stuff. So it's really interesting how, as people use DSLs more, these somewhat more advanced or less obvious topics become more important.
Yeah.
Agreed.
So downsides, there have to be some.
Yeah.
Well, I always find the language cacophony complaint an interesting one, because if you are doing your domain-specific language properly, that language expresses the domain. And unless you believe that you can effectively program within an application context and not understand the language of the domain, yes, you've applied a formal syntax to it and you've applied a formal semantics to it rather than this more informal notion that we often carry around in our head whenever we're programming in a particular domain. But those domains exist, and those languages exist. And so I think all we're doing in this context is making those things more explicit, and perhaps because we are being more explicit about the existence of these different languages, the places where these languages interact or intersect, or perhaps, heaven forbid, conflict, will become more obvious because we are talking explicitly about these languages rather than them lurking in the background without us paying attention to them. So that's one that I have a difficult time actually calling it out as a disadvantage.
Yep.
To me, it's more a feature.
Mm-hmm.
Yeah, it just occurred to me we might have to go slightly meta because we didn't explain what the language cacophony problem was. So I'll explain it, shall I? You may want to put this in front of...
No, we don't do
I'll
this.
leave it up to you.
Yeah, no.
So the language cacophony problem is basically saying, well, if we start using DSLs, then this system, instead of just being a Java system, it's got 30 languages in it, and people are going to find it much harder to learn and understand because I've got to deal with 30 languages instead of one.
Well, otherwise you deal with 30 frameworks. How is that
exactly?
Simpler? I mean,
that's the counterpoint to that, of course. You've got to learn the frameworks anyway. And if the languages are any good, then they make the frameworks easier to deal with. Right. Now, of course, a bad language is going to make things worse, but bad stuff always makes things worse, and there are plenty of bad frameworks out there.
Yeah. Right. Okay, so let's put that into the undecided category, but there must be some real disadvantages.
Well, there's a real cost of building. Yeah. I mean, you have to build the necessary constructs to make a domain-specific language, and that entails some cost of building and some cost of maintenance.
Mm. Yeah, and I think, too, particularly when you think about domains that are changing rapidly, it's one thing to modify your code and modify your test to express a new business environment. If you have a lot of your business logic encapsulated in a domain-specific language, and the business context changes to the point where you want a different language, you have a very different kind of migration problem on your hands in terms of how do I map this domain language to this new domain language. So I do think there's questions around what does it really mean to evolve a language, what does it mean to migrate old scripts across the evolution within the domain-specific language, so I do think there's a complexity there that we really haven't figured out how to grapple with.
And this also leads to what I find is one of the interesting comments that's not just true of domain-specific languages, but generally in frameworks as well, which is you have this tendency to create blinkered abstractions, where once you've got a good abstraction, it kind of puts your blinkers on, and you can't see things that don't really cleanly fit into that abstraction. Yeah. And there's, I think, a reasonable argument that domain-specific languages can exacerbate that problem. I mean, you get it in any case, But if you've got a really nice DSL and a really nice abstraction, then yeah, I can see that there's a definite danger there that you're not going to see things that fit outside of it.
Yeah.
I think that there's another issue too, in that we really don't yet understand what constitutes a good DSL. And so the probability of creating a language that doesn't necessarily serve the needs well of the users, particularly if the focus is on this, we're going to sit our domain expert down with our developer and have them pairing on this. If you've got a bad language, you are probably going to make that communication channel worse rather than better. And we still really don't know how to approach language design in general for a DSL. There's still a lot of questions out there on what constitutes a good language design. We can talk about it very conceptually. Well, it should naturally express the concepts. But what does that mean? How does that manifest itself when looking at a particular domain and a particular language? And so we do have the possibility of making the process worse rather than better if we don't get the language right.
Mm. Yeah, I just always think, what's the alternative? Not having a language at all, using Word documents, or using bad frameworks. Bad frameworks which don't capture the domain are also a problem. So I guess whenever you're trying to solve a whole class of problems or a whole domain, then you always have the problem of what is the right abstraction and how do you fit in the 20% that don't fit the abstraction. So, So the question is, how quickly can you... Well, so Maybe if you have a domain that evolves quickly, maybe you have to build a language that allows you to build some abstractions in the language, so you don't have to change the language if some abstractions change. Things like that, right?
Yeah, although if it's really fundamental changes to the language, then I think there's an issue, because the ability to build new abstractions in the language is, to my sign, another sign of a general-purpose programming language.
Well, I agree, of course, but on the other hand side, I have seen examples where it does make sense in some limited cases to for example, very, very primitive case, I have a bunch of hardware building blocks. Another question is, what properties can I ask this hardware about, like temperature, speed, whatever. And if you code that into the language, that may be bad, because if the driver now supports an additional data value, you have to change the language. So rather you put it into you define these things in the language, things like that.
Yeah, but again, I would say the word that you used there was limited.
Yes.
Right, it's limited abilities to build new abstractions is okay.
Yeah. Right. Domain-specific abilities in some sense. So, we already tried to we of course prepared this episode, right? So we have a script a little bit, and the next thing is DSL lifecycle, and it talks about what makes a good DSL and the idea of layering over a model. We talked about these things already, right? So is there anything you want to add in that space?
Well, I think one of the questions that I often get asked is how does this really manifest itself in the software development lifecycle? Mm-hmm. If I have a problem, how will I go about knowing it's time to have a DSL, creating the DSL, if it's an external DSL, creating the language parser? How does that then translate into impacts on my build system? How do I deal with language evolution? I think one of the interesting examples that we have about this in a more limited way is the use of more business relevant DSLs for building automated tests. So things like Twist and Cucumber and some of those testing frameworks where you have kind of a middle ground where people who are trying to express acceptance criteria for a system are using something like a DSL to specify their intention of the test. So you have, in a context like that, you might have a DSL that or a DSL-like thing that is being used for testing, as well as a DSL that is being used to actually more directly express the program. Mm-hmm. So when we look at the life cycle, it's the creation and evolution of the language. It's the creation and evolution of the language processing aspects, whether that be the implementation within the internal language or the building of the language processor. Then we look at, particularly in the case of an external DSL, the impacts on the build pipeline. And then we look at, what do you have to test with a DSL? You obviously want to make sure that the translation between a particular sentence in your language and the semantic model is correct, we can probably, if we're doing external DSLs, feel fairly confident that parser generation tools are going to generate the right kind of parser, but are we actually associating the right semantics to the particular output of the parsers? So you want to test the language processor itself, but then you also have to have a mechanism to test the DSL script itself. So I've put together a program for something. What does it mean for me as a user to test this? And how might that testing phase fit into a standard build pipeline? So those are some of the aspects of the life cycle that we have to look at. And then, of course, as the language evolves, how do we migrate scripts that have been written in that DSL so that they operate in the new version of the language?
Right. Yeah. And a lot of this stuff depends quite a bit on the tooling, right?
Exactly.
And can't be discussed in general, I think.
Mm-hmm.
Yeah.
So, what do you say to people who say, I've studied computer science 10 years ago. I never really understood this whole grammar and parser stuff. It was always the hardest thing, compiler construction. And now you want to make me build my own languages? Forget it, right?
Well, as I always say, there's a common fear of writing parsers, and there's two reasons why people have this fear. One was because they didn't take the compiler class at university and therefore think that parsers are scary.
I think I know how you.
And the other reason is that they did take the compiler class at university and they know it was scary.
Right.
But the problem, of course, is that all of these classes taught parsing in the context of general-purpose programming languages.
Yeah.
And trying to parse a DSL is a very difficult exercise from trying to parse a general-purpose programming language, especially if you pick something like C, which is a horrible thing to parse anyway. And that's really the difference. A little DSL is not at all difficult to write a parser for, particularly if you use a parser toolkit. But even if you do some simple technique like parser combinators, it's not really that tough, as long as the language is relatively simple. And again, by separating out the semantics into a semantic model, your exercise is then just populating that semantic model. And it, again, simplifies the exercise considerably, I think.
And that there are well understood, at least in the language processing community, well understood concepts of what languages are hard and easy to parse. And we actually have much better tools. Many people who took a compiler instruction class actually use Lex and Yak.
Yeah.
And Antler, as an example, is much easier to use. Parser combinators are much easier to use than Yak, although I do have a fondness for Yak. I have to. I used to teach one of those compiler courses after all. But the important thing is there are things you can do in the design of your language syntax to make it easier or more difficult to parse.
Yep.
And the other thing is DSL programs or DSL scripts tend to be shorter than large programs. It's probably also a smell if you've got a 1,000,000-line script in a DSL, and yet we do have to do things like compile huge programs that have complex relationships between the different parts, and part of the drive for the DSLs is to try to think of things in a more limited context, and that is going to result in smaller scripts with potentially fewer interactions between various parts of the scripts. And so all of those things are going to make the language processing problem easier.
And to take your argument one step further, if you have relatively small programs, you can use relatively bad performing parser formalisms.
Correct.
And that is why, for example, the guys working with Elko Fischer, they use SDF, which is a GLR parser, which makes writing grammars much easier. It's a bit slower than Antler, but who cares? We have fast machines and small programs.
Exactly.
Right? And I guess another argument you could make is if you use tools like Xtext and you actually go through the trouble of writing a grammar, which may be hard for people, maybe not, I don't know, but you don't just get a parser, you also get an IDE. So you get more for your work. So that's even another argument that people may want to.
Mm-hmm.
Yeah, and I suspect actually grammars aren't that scary because people use them all the time to understand how a language works. It's a relatively common thing. It's just all the other stuff, and particularly when you deal with a much more complicated language.
Yes, right.
I mean, it really came home to me when I was preparing some examples for the book, and I I used the example that I used in the first chapter, which I should mention is available as a free download, so I'm not necessarily advertising the book here. And it's basically a simple state machine. And at one point I did it using XML, because that's, of course, a common way of doing a DSL is to wrap it up in XML, and that way you don't have to write a parser.
Yep.
So it took me a morning to take the XML script and write the necessary processor to populate the model from that. And then the next day, I did a custom language and used Antler, and again, it took me a morning, exactly the same amount of time.
Yep.
And I actually used a bit of Antler I'd never used before, just because I felt that would be easier to talk about in the book.
Yep.
So there's a bit of learning curve involved. Now, okay, I'm a bit more used to than perhaps the average person is at Antler, but not that much. And the point is, it's not really that much harder to use those kinds of tools to parse a simple language.
Yeah. And then, of course, there is one other way to look at it. If you don't like parsing, then don't use it. I mean, there are these projectional editors which don't parse. They may have other challenges, but you don't have to do this grammar stuff. So.
Right, and that's internal DSL's argument as well, of course. You don't have to parse then.
Exactly. Right. So, I guess we already mentioned this notion of language workbenches. At least I'm not sure we actually mentioned the word, but we talked about...
I don't think we have yet, really, yes.
So we should. So why don't you try?
Okay, so we've already talked about internal and external DSLs, and I see those as two main classes of DSL. And then the third one I see is language workbenches, which is a fairly broad phrase used for tools that are specifically there to allow you to design and build not just a language in how we normally think about a programming language, but a whole environment for interacting with a language. The examples that triggered this, I guess it was back in around 2005 or so, when I first started looking at what Attentional Software was doing. I first started seeing what MPS were up to, and some Microsoft efforts as well. But I would say Intentional MPS were my first two introductions into this space. And they struck me as, there's a lot of interesting common elements here. You are describing some kind of meta model in some kind of meta modeling environment to lay out your meta model. You typically define some kind of editor that allows you to manipulate your language in a much more rich way than just simply typing text. And then there's typically some kind of tools to allow you to do code generation out of that so that you've got something that's really executable. You're not just sort of doing what a case tool might do and wander around waving your hands a lot. You actually are executing something. And that really struck me as a very interesting approach because, I mean, there are lots of limitations to thinking of text as a sole input medium. Now, I think there are huge pragmatic advantages.
Sure.
Our whole industry is focused around text. But once you get away from that, it was brought home to me quite nicely. One of our former colleagues, Matt Femmel, was talking about how when programming in a modern IDE like IntelliJ or Eclipse, a lot of the time you're not typing anymore. You're just hitting Alt-Enter to do it, giving the IDE a hint and then putting completion codes, and the IDE is then building much more.
Yep. And
you've got a sense of, I'm not manipulating text here, I'm manipulating a real model of the program. And of course, what a tool like an MPS does is it allows you to really get into that much more. And I think these are very interesting tools because not just could they allow us to do what we currently think of languages more intriguingly, but also to go a step forwards. I mean, we've talked about how I think Excel is this really quite rich language environment. If we really want to have something that's going to communicate very deeply with domain people, we want to build languages like Excel. And that requires these kinds of tools.
Yeah.
So I think the potential here is huge. The question, of course, is how far are we along, how far will it take to be practical, etc., etc.
Yeah.
One of the other benefits I see as a consequence of the language workbench approach is the freedom that it gives you in terms of designing your DSLs. You can be more focused in the design of your DSL because this language workbench environment particularly on the intentional side, perhaps not quite as naturally, but I think it's still a feature of MPS, where these languages, it's easier for them to cooperate with each other. So you can say, I am going to talk about persistence over here, and I'm going to talk about aerodynamic modeling over here, and I'm going to talk about metallurgy here, and I have the infrastructure that will allow those DSLs to cooperate, rather than trying to figure out how am I going to get something that's going to be natural to a metallurgist and the aerodynamic engineer at the same time.
Yeah.
So I do think that that's something that is going to be critical to the development of domain-specific languages, is this ability for the languages to interact. And the workbenches make that far easier than even the more traditional programming language processing approaches.
Right. I'm in the lucky position of being able to spend a lot of my time currently working with MPS, and we have actually built an extension of C that uses a table notation for decision tables, for example. And so this stuff really works. And also this whole thing about language composition, language modularization, extension. I mean, it's unbelievably cool what you can do. Now, I mean, you can also do it with text-based tools to some extent, right? So would you include Xtext would you call that a language workbench? Although
I generally do, yes.
Okay. So
it's got different styles, but it's still broadly the same thing.
So that was my impression as well, that you've kind of removed this constraint of being projectional to make something a language workbench.
Right. Yeah, I did write that when I wrote the articles in 2005, because everything I'd seen was projectional at that point. But in fact, Xtext was a counterexample of something that came in without any kind of projectional capability and clearly fit well enough to fit in.
Yeah. I mean, if you invented, programming again today, I mean, no sensible person would restrict themselves to 7-bit ASCII characters or Unicode. So I think from a conceptual perspective, this projectional stuff is completely convincing. And the tools are also really getting there. But of course, there is this whole thing about integration with existing worlds.
Yeah.
Well, there is also the change in the way you think about solving a problem. And we have an entire army of software developers out there who think about solving problems in an OO fashion or in a functional fashion. And how you approach a problem is very different if you are looking at it from the perspective of a DSL. And I think that this is going to be an interesting transition for us as we start to experiment with different places DSLs can be used. I think we're going to be attacking it from a couple of different angles. The technical domains, we already have lots of DSLs, and I think we're going to see that continuing to advance. There are many things that people are already quite comfortable with thinking about as a DSL. Rules languages are an obvious example, and the concern I actually have is that people will be so focused on using a DSL to represent a rules language that they'll miss the more general aspects of it. But I do think we're going to see that this movement towards thinking about problems differently, but there's a long way to go before the average computer scientist coming out of university is going to think about solving a problem in this way.
Yeah. It really changes your worldview if the language is not a constant, an unchangeable constant anymore. And
yes.
When you talked about these alternative computational models, I mean, imagine you could reuse a state machine language and then embed a domain-specific action language into it. Right? Things like that actually become possible. So it's really cool.
Yep.
Yeah, I mean, that's one of the things that is the problem with doing anything like the book writing I did is you always have to kind of put limits about what you do. And one of the sad limits was really deciding I couldn't really delve into the language workbench area. And I haven't really looked that much more in it over the last year or so. But it is something I need to look more at again because I think it's got such potential.
Well, let's put it this way. Initially, when I read your book and noticed that you didn't talk much about domain of language workbenches, I was a bit frustrated. But then I thought, actually, this is great because now I can write the book on these tools.
Exactly.
And so everything has two sides, I guess.
Yeah, exactly. And I do think there's a huge amount of potential in that area. It's kind of odd in a way. People are very excited at the moment about new languages and functional languages, the Scalas, the Clojures, the F-sharps, and all the rest of it. And I must admit, part of me feels kind of, well, no. I mean, the really interesting stuff is what you can do with a language workbench.
Yes.
If that amount of attention moved into that space, then I think that's where you're going to get a really big shift.
Yes.
I think the other languages, they can make small gains, but the really big gain would come through the language workbench direction.
Yeah. So, we are at the end of our prepared notes. Did we forget anything? Is there anything you want to add that I kind of skipped or that kind of didn't get the necessary attention?
Nothing leaps to mind.
No, I got in the points I wanted to make.
Okay, if we were television, you should now, put your book into the camera so people can see it. So we have to do that verbally.
Yes.
Yeah, we're on Skype here. So, I mean, the book is called Domain-Specific Languages, and the author is obviously Martin Fowler and Rebecca. So people should be able to find it.
Yeah, easy enough to hunt down.
Yeah. Okay. Good. Then I thank you very much for being on the show. It has we've been planning this for a while, and I'm really glad that it worked.
Yep.
As am I. Thank you.
I guess then that's it. Thanks for being on the show, and talk to you sometime soon on some conference.
Yeah, hope so.
Thank you, Marcus.
Bye. Thanks for listening to Software Engineering Radio. SE Radio is an educational program brought to you by Hillside Europe. If you want more information about the podcast and the other episodes, visit our website at se-radio.net. If you want to support us, you can donate to the SE Radio team via the website, or you can advertise for SE Radio, for example, by clicking on the Dig, Reddit, Delicious and Slashdot buttons, or by talking about us on Twitter and Facebook. You can also support us by joining the team and shouldering some of the work. To contact the team, please send email to team@se-radio.net, or if your feedback is specific to an episode, please use the comments facility on the website so other people can react to your comments. This episode of SE Radio, as well as all other episodes, are licensed under a Creative Commons 2.5 license. Please see the website for details.